Hi, we're back. Okay, so today talking about Chapter 6, using GIS for spatial analysis. So as I said in my little intro on the course page, this to me is, not just to me, it is for a fact the purpose of doing GIS is spatial analysis. You can't do GIS and not do spatial analysis. That is the point of why you are taking geospatial data and putting it and visualizing it in a mapping system, so that you can analyze problems based on spatial data. So as I indicated in my description, again on the course page, it's all about being able to search your data using the correct search terms and doing what's called spatial analysis. To start, I'm going to give us a little history lesson and talk about spatial analysis before computers. So nowadays we have computers, as we know, that do all of the heavy lifting for us. They do all of the intense mathematics and calculations that we ask it to do that go into analyzing the data that we have contained within our mapping and our geospatial data. But before we had computers and before this was even a glimmer in people's minds, I think it's become, it wasn't the idea of connecting events to a location and trying to solve problems with it. That wasn't there, and it didn't really come around until Dr. John Snow solved the cholera outbreak in London in 1854, and this is widely accepted as the first example of spatial analysis. It's also the beginnings of epidemiology. As John Snow sought to figure out where this cholera was coming from, because it was previously believed to be in the air, to be something that floated around in the vapors. So what John Snow did, this revolutionary idea he had, was to go around to all of the households where there was cholera occurring and ask them what well they drew their water from. Simple as that. And everywhere he had cholera outbreaks, he wrote down the address, wrote down the name of the people at the house, and he wrote down where they got their water from. And very, very quickly, without a ton of work, he was able to trace it to this one well in London that was then shut down. I have included a video link on the course page too that I think really helps to sort of illustrate the drama. It dramatizes it a bit, but the importance of this moment in history, and medical history, and urban history, and mapping history for everybody. So when I brought this example up is because I think it helps to really clarify what is meant by spatial analysis. As we already know, GIS and using geospatial data is about finding the relationships between items of geospatial information. So by relating the location of objects and phenomenon/people, the geospatial data, to each other using their attributes, which is that non-geospatial data we discussed last week, we can solve problems. So in the case of John Snow, death by cholera would be considered an attribute of a household that has a known location. So other examples of attributes in the cholera mapping example would be people's names, their gender, their occupation, and most importantly, where they got their water. And by doing that, you can visualize it on a map. And then what happens is when it's on this map and when it's also in a computer, you can further analyze it for deeper patterns and more meaning. So here I wanted to give you an example of a little bit more of the power of that visualization and mapping can do. So I'm going to pull up this example here from Esri. Give me just a second. Oh, it's not going to let me do it without being in the computer screen. So I'll open this up here. Never mind, it's not working. I'll put the link on the course page. It's just a nice video Esri put together of some of the powerful things you can do with visualization and some minor statistical analysis. So just to conclude here, I think this is the last slide, these are some important concepts that are going to come out in the chapter, and these are really foundational to continuing on with GIS if you choose to continue on with it in the future. And you've probably seen these concepts before if you've ever done any kind of research in the library or done any library science stuff. You've seen Boolean operators. We actually use them a lot without even knowing it, just when we do internet searches. So in our case with GIS, we use what's called relational operators, Boolean operators, and structured query language, also called SQL. Relational operators are these guys. So we have our like greater than, less than signs, greater than or equal to, less than or equal to, like that. I guess we can recall those from our math classes. The Boolean operators are these phrases here, and, or, not, or XOR. Saying that is always a little hard. And what this results in is structured query language. And we also have what are called queries and compound queries, which are just like basically thinking of simple equations versus compound equations, if you want to think about it. So on the one hand, we have 1 plus 1, or we can have 1 plus 1 in parentheses times 3. That would be a compound query or compound equation. So what these operators are actually acting on is the information that we see down here in our attribute table. So this attribute table is what this looks like in tabular form. I don't know if these are exactly the same thing. I don't think they are. But in general, the idea is that if this is what you're seeing in your ArcMap, is this image here of a mapped area with some, looks like parcels and streets, and we have red dots, then all of this data that we see here actually looks like this if it were in a table. So when we do these searches, these queries, it's digging into this information here. Now over here is what the query interface looks like. So when you go through your exercises in this week's lab, you'll be working with this window. And you can see here we have our relational operators, we have a Boolean operators, and this is where we set up our SQL. So it's, again, quite logical. It's quite interesting. I think it helps to prepare the way for some deeper analysis. And if you enjoy doing this, you can actually achieve quite a bit and go really far and do some very interesting things with GIS. So, and as I was saying, you can go farther. You can go much farther. And these are some of the ideas that we will not explore in this class, although I think I might go over a few of them with you just because they're good to know. Things like buffering, overlaying, uniting information, intersecting it. Where does it overlap? Finding the identity of things, looking at symmetrical difference, map algebra, which is a little more complicated but very fun, site suitability, distance surface calculations, and so many more things. All of these are related to spatial analysis. So I will leave it there for now, and good luck with the chapter.